Please take a look here. This is within one minerals, the orientation of cutting. You have a mineral. For example, you have one mineral. You cut the mineral in this direction or this directions and interact the light with it. So this is a refractive index and this is refractive index. In this direction, within the same mineral, in this direction, the velocity of light is more faster than this direction. The velocity of light is slow in this direction while the velocity of light fast. Due to what? Due to more electron density in this direction. You have a plane, so the velocity of light in this direction are more slower than in this direction. So maybe for better understanding, I will show you this photo. If we have a calcite mineral, we want to know how the velocity of light behaves. When the light is perpendicular to what? To the Roham phase. This is Roham phase. We have a maximum slowdown of light. Maximum slowdown of light. While if we have this prismatic crystal and we cut it in this direction, we have a fastest direction of the what? Of the light. So depend on the direction, the velocity of light within the same mineral change. This is due to what? Due to the crystal structure of the minerals. So we want to know, we talk about refractive index, different between velocity of light in vacuum and velocity of light in mineral. So we want to know how to measure refractive index in a mineral, how to measure refractive index in a mineral. We have two methods to determine the refractive index of minerals. First is a immersion method. Immersion what? Immersion means you have a mineral and immerse in what? In a liquid. The liquid are of known refractive index. For example, you have a like this, and we have a liquid of known Ri, and we put the mineral in it. We have a three case. If the boundary of crystal, the boundary is visible, we say that the mineral of higher, the value of refractive of mineral is higher than that in liquid. Higher than that. If the boundary is not clear, the boundary of mineral is not clear in a liquid, we say that the refractive index is lower than the liquid. If you see it if you see it approximately the boundary, you say that the refractive index. So we have a grain, and liquid. In our case, the refractive index, if we consider the refractive index of our liquid is equal to 1.5. 1.5. It's unitless. Do you know why? Refractive index is unitless. Unitless. without unit. Why? Who can tell me why? We have a n, this is a refractive index, equal to what? Equal to velocity over velocity. Both have the same, for example, meter per second and meter per second. Okay? So this go with this. So the refractive index is what? Is unitless. Unitless. Let's consider we have a grain, we have a crystal with higher refractive index. With high, we have a grain 1.55. We have 1.5. So let's see what happened. Please take a look. The boundary of the grain, is raised above what? Above the liquid. The boundary is above what? Above 1.5, because here we have 1.55. 1.55. If it's equal, this is equal. We have a grain with 1.5 and the liquid is 1.5. So it's not clear. The boundary is not clear. So this is the method we can find the refractive index by this method. Another method, we have a Bicky line. Bicky line. Bicky line is formed due to the difference of velocity in light and the mineral. Velocity of light and the minerals. So let's consider if we have a high refractive index. Please take a look to this. This is the grain. And look at the boundary, please. The boundary move outward. 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 What does it mean? This is suggests that, please take a look. The grain boundary is moved outward. This movement of boundary, white line, is called Bicky line. Bicky line formed by difference between velocity of mineral in light and air. And let's take a look at minimum the movement of Bicky line, the white line, toward the center of the grain. Can you see it? The movement is toward the center of the grain. This suggests that the minerals are of lower refractive index. So this refractive index I talk about, this is a function of chemistry, crystal structure, and what? And the density of the minerals. So in mineralogy, how can we represent this refractive index? We can present it